Hi students. So today we will discuss the second part of our center of mass. No, I already discussed center of mass part 1. Please watch it and come back to the part 2. Actually I thought of doing a same single part, no, but it is becoming of lengthy, no. So that's why I split into two parts now, right? Here we'll will focus on the motion of our center of mass. In the first video, I already taught how to calculate the center of mass of a different methods and how to solve the problems based on the center of mass, right? So watch that first video and come back to the part 2. So therefore, motion of the center of mass now. See, center of mass, therefore center of mass means what? Total, right? The total mass of this one is going to act at one certain point onto this, like this. So if you are exerting the force on this one, therefore this total whole body it will be able to move. So while it is moving, therefore how the center of mass it will be moving and how it will be act onto this one, how the external force and internal force will show the effect on the center of mass, no. So we'll see different applications here, no, right? Yesterday we discussed, I mean in the part 1 we discussed, no, that is center of mass can be calculated as m1 r1 vector plus m2 r2 vector, so on, by therefore total mass of these particles now. Clear? So if you want to calculate the velocity of the center of mass, no, therefore do the differentiation on this one, no. So velocity of the center of mass you can write down, so drcm by dt, therefore you can write it as m1 dr1 by dt, therefore v1 plus m2 into v2 plus so on by m1 plus m2. Here vectorially you need to add it on to this. In this way you can calculate the velocity of the center of mass, no. Let us see here, no, velocity of the mass into velocity means nothing but a momentum. Here this total mass, no, taken here, no, total mass and total velocity of the center of mass, it will be equal to m1 v1 plus m2 v2 plus m3 v3, so on. Vectorially you need to add. That means momentum of the center of mass will be equal to sum of the momentum of all the particles, so on. Clear? So this is your momentum of your center of mass now. Clear? Similarly, again we can calculate it as total force, no. So that is total acceleration, no. So here again do the differentiation here, no. So acceleration of the center of mass, no. Therefore dvcm by dt. So again differentiate it, no, m1 a1 vector plus m2 a2 vector m3 a3 vector, so on, by therefore m1 plus m2 plus m3, so on. Clear? So here we can rewrite it as acceleration of the center of mass, it will be equal to force acting on one particle plus force acting on second particle plus force acting on the third particle, total force, no, total mass of this one. In this way we can calculate the acceleration of a center of mass. So mass can be taken here, no, therefore force acting on the center of mass, no, therefore force on the center of mass it will be equal to total mass into acceleration of the center of mass into force acting on each and every particle. Vectorially you need to add it all this. Clear? So this already I discussed once in the in our first part, no. Let us see, you know, here force acting on this one, no. Again conservation of your linear momentum, no. That means if external force acting on the system is 0, that means if there is no external force, only forces are acting on like internal forces will not make any object to move on to this, right? So only external force, no. So if it is no external force acting on the system, so therefore total momentum, right, inside the particles, no, the total change in momentum it will be equal to 0. So that means change in momentum it will be equal to 0. That means total initial momentum will be always equal to total final momentum. Clear? Now total force acting on this one. So therefore what you can write it now, total initial momentum and total final momentum will be equal. If there is no external force acting on the system, no, so therefore there is no acceleration on the center of mass. Therefore, so here acceleration of your center of mass, it will be equal to 0. That means velocity of your center of mass, it will be constant. Clear? That means, so we can have a lot of applications on this one. No? Let us see 1 or 2 applications based on this one. No? I explained this one now based on the law of conservation of momentum concept. Now please go through it. All the problems of related to this also I explained onto this, right? So what is this one now? Let us see here. No? Suppose there is a one explosion is there now. Suppose one bomb is there now. Therefore, initially it is not moving, it is at rest now. So where the center of mass it will lie now? At the center it will be the center of mass it will lie. So now therefore it is now exploded. This explosion takes place because of due to the internal forces, not external forces now. When it is exploded, therefore it is made it like a some 2 parts onto this. So what will happen now? This m1, therefore it will go with a velocity v1. So it is m2, definitely it will go with the velocity is v2. Why? Initial momentum was 0. So totally final momentum also should be equal to 0. That means this momentum and this momentum should be the same. Right? That means here the center of mass is there. Now momentum is same. Momentum is same means what will happen now? Definitely the center of mass where it is initially where it is lying now, here only it will be the center of mass, it will be there onto this. Center of mass will not move toward this side, center of mass will not move toward this side. Right? Even though the different particles, no, they are going with a different velocities, but their momentums are same, no. Therefore, the center of mass, even though it is here, after that particles are here, after that particles will be here, but even though, therefore, the center of mass of these 2 particles, no, will lies at that same point. Even not only 2 particles, no, if it is 100 particles are there, it is exploded, so the center of mass it will be still lies there only. Suppose if this object was moving, right? So how the center of mass is moving? While it is moving at some point, no, it is broken into different pieces. Again, the center of mass will continue the path. Why? Because there is no other external forces, no. Only internal forces are there. Let us see one example here, no. Right, we studied projectile motion, no. Let us see here, no. Here we are projecting one small particle here. Therefore, one explosion we are projecting now. So this is going. So this it will be the path of your center of mass now, right? So how the path it will be there? It is like a parabolic path. Suppose at a topmost point now. Suppose at topmost point, therefore it is exploded. It is exploded. At this point, explosion was taken place now. It is given as like a different particles now. It is going in a different speeds now. But what will be the path of the center of mass? This is very important, no? So what will be the path of the center of mass? No, this explosion is taken place because of due to the internal forces. So no external force acting on the system, no. So here how the center of mass is here. So therefore the center of mass of these different particles where it is far away, that all particles, no, center of mass will lie at this point, at this point, at this point, at this point. So therefore center of mass will follows a parabolic path. So there is no deviation, even though the single particle is there. After that, some particles are going different speeds, no. So therefore, the center of mass it will follow the same parabolic path onto this. Clear? One more example here, no. Let us see here. Suppose this is one object is there, m1, and this is another object is there, m2. They are kept at some distance. This is your question. So many times it is asked in the examination, no. This is kept in the gravity free space, no. So these 2 particles are coming closer, therefore are moving towards each other. How they are moving? Because of due to their mutual gravitational force. So the gravitational force between them, no, g m1 m2 by r square, right? So they are moving because of due to their mutual gravitational force, right? So when these 2 particles are there, therefore the center of mass is here. So now as these two particles are coming closer onto this one now, therefore even though as they are moving onto this one now, therefore the center of mass it will be still going to lie at this point only. Why? Because this mutual attraction force is nothing but a internal forces now. Therefore the center of mass it is still going to lie, no. Where they are going to meet it, no, definitely they are going to meet at their center of mass onto this, right? So therefore when they are moving, therefore if there is no external force, if there is no external force acting on the system, so there will be shift in the center of mass. No, therefore there is no shift in the center of mass. That means no shift in center of mass. Clear? So that means the center of mass, it is going to lie at the same point after this. Clear? So where they are going to meet it now? Definitely they are going to meet at the center of mass only. So one more important application now, I already did this concept now in the law of conservation of momentum. So there is a one, suppose there is a one boat is there now. Suppose let us take this one now. Okay, we'll take it as different, right? One more no. Therefore let us take this one. Here very important application now. So suppose there is a one plank is there. This is one plank. This plank is kept on a smooth surface now, right? So this plank mass is about, suppose it is m. This concept I already explained how to solve the problems related to this one now in a so law of conservation of linear momentum. So now therefore here there is a person is there now. This is one person. Clear? So this person mass is m. Now the plank is L. So therefore this plank is kept on a smooth horizontal surface. There is a smooth horizontal surface. Where the center of mass will lie now? Definitely, so here this side mass is more. So definitely the center of mass it is going to lie. So at this point onto this. This is here the position of your center of mass. Now suppose here, okay, now the center of mass is going to lie. If this person was not there, it will be at the midpoint onto this. Now what happened now? If this person moved to other end, that means he came to here. So when he is moving back, moving toward this side, therefore this plank it will be going backward onto this. Clear? So that suppose if this person is going toward this end, no, this plank it will be going backward onto this. So what will be the shift in the center of mass now? See here. Therefore what will happen now? Let us see this. So here, therefore here it will be, we'll take it now. So this is your path. Now we'll take it as one plank now. Therefore you try to observe this path, this person is moving, this plank will go back. So this plank will come to here. That means plank is moving back. Clear? So now what happened now? Therefore the person came to this other end onto this other end. Therefore, so when he is moving, no, this plank is going came back here now. So where it will be the center of mass is lying now? Again the center of mass here at this point is there, no. Therefore again if you take it, no, therefore the center of mass, because he shifted here, no. So therefore it is when he shifted here, no, therefore here it will be there. So there will be a shift in the center of mass. I mean, so here also this plank is moving with respect to this one, no. So therefore here also the center of mass is there, here also center of mass is there. So therefore there is no shift. There is no shift. Shift means position changing. There is no shift in center of mass. Clear? So there is no shift in the center of mass now. So that means here shift is not takes place now. So but this plank it is moving certain distance onto this. So we calculated how much amount of distance is moved. This plank, no, I already calculated. So by using this concept now, there is no shift in the center of mass, right? So we can calculate it here, no. I already told you, I already did this type of concept, no, how to solve the problems. Very easy, very simple one, no. So when there is no shift in there, no, therefore what you can write it now, delta x in the center of mass, no, it will be equal to 0 because all motions are takes place along the x axis. So therefore m1 into delta x1 plus m2 into delta x2, it will be equal to 0. So m1 means mass person, no, person of this one, no, m. How much distance he will move now? Therefore the length of the plank is L. Can you tell me how much distance he will move? He will not move the length, no, length L. Why? Because while it is moving, this is going backward onto this one, no. Suppose it is traveled some x distance here, no. This is here x distance, no. So therefore he will travel L minus x distance. That means it's toward this side, back side. So this is your positive x axis. This is your negative x axis. Is going toward this minus. So here is going toward this side, positive, right? So therefore the plank is moving in which direction now? Backward direction. Mass of the plank, how much distance it will move now? It will move x distance minus x distance, it will be equal to 0. That's all. Simple thing, no? So this type of different questions, no, I already did in a law of conservation of linear momentum. Please check out that concept. Check out that video. right. So then you can solve it now, very simple one. No? So here m into L minus x, it will be equal to mx. Therefore here m into L, so taken here, no, therefore x taken common, m plus m, that implies x is equals to small m by capital M plus small m into L. This is your so this much amount of distance it is moved by this plank in the backward direction on this. Clear? So these type of problems, no, not only here, so therefore here even the boat, this is a boat is there, no, if the person is moving from one end to another end, there is no shift in the center of mass, no. So how much distance it is moved, no, you can calculate like this pattern onto this. Clear? So suppose if a person is sitting here, is shifting towards one another position, no, the boat is moving. Here one important point it is then, no, suppose it is kept on the horizontal smooth surface, no. So this is your smooth surface. Suppose this is fixed, that means this is not moving, it is a fixed one now, Therefore in that scenario, therefore what will happen now? So if it is completely fixed onto this, so suppose therefore this is kept onto this one, no, this is one plank, it is fixed onto this. Suppose this person is there, now here it is here, so this is total m. So where the center of mass it will lies, no, center of mass it is going to lie at this point. Why? So this plank and this mass is m. Now this is fixed onto this, therefore it is not moving. So now, but when the person comes to other end of this one, no, therefore when the person comes to other end, so when this person comes to here other end, so here there is a mass is there. So what will be the center of mass here now? Therefore center of mass it will be here. So new center of mass it will be here now. Clear? So there will be a shift is taken place now. When? So when this plank is fixed. Clear? But when the plank is in the kept on the horizontal smooth surface, no, so it will be, so there is no shift. Why? Because he is moving and this much amount of distance he will go, right. If possible, I will keep the video here, no, just observe that video so that you will get one more clarity onto this one, right. Observe the videos here. Clear? So let us solve some problems onto this one, no. So now let us go for one problem here. Right. So always use the vectors, that's all we can write, Here this is your 1 kg object is there, this is your calculate velocity of the center of mass. Here 1 kg object is there now, right. So 1 kg object is going with a 10 meters per second. So therefore what will be the velocity of 1 kg now? Velocity of 1 kg is nothing but 10 into 1 velocity, here no, velocity it will be equal to how much, no, 10, this is your x axis, means I cap. So this is your how much now? One more 2 kg. So velocity of this 2 kg, what you will get it now? Therefore this velocity it will be there, this side velocity it will be also is there now. Therefore you can rewrite it as 10 root 2 into cos 45, means 1 by root 2 get cancelled out, no, 10 meters per second along the x axis and 10 meters per second along the y axis, j cap, right. So 10I plus 10j. Now you got it, no. You can solve the problem very easily. Velocity of the center of mass, it is m1 v1 plus m2 v2 vectorially by m1 plus m2. Clear? So m1 is nothing but 1, velocity of 1 is how much now? 10 I cap plus, therefore this is mass is how much now? 2 kg. So 10 I plus 10 j cap by, therefore 1 plus 2. So how much it will be now? 10 plus 20, 30 I cap plus 20 j cap divided by 3. So get cancelled out, no. So you can split it here. So what you will get it now? 30 by 10, therefore 10 I cap. So 20 by 3 j cap. What will be the velocity of the center of mass, no? So velocity of center of mass, it will be equal to 10 I cap plus 20 by 3 j cap. Clear? In this way you can solve the problems, right, very easily. Always depends on the like vectors, no, so that you can solve the problems very easily. So we'll solve one more problem, no. Yeah, this also exactly the similar way. So right, always stick on to one simple concept, no, right. So that is you have to use the vectors in this one. This is your velocity of this one is 5. So you can rewrite it as therefore 5 into cos 37. So this is 5 sin 37. I already told you 37 and 53, right? If you forgot it, no, please take it this one, no. So this is your 3, 4 and this is 5. This should be 37 and this should be 53. Now you can write it as therefore here 5 cos 37. Cos 37 means how much now? Cos means 4 by 5. Adjacent side by hypotenuse by 5. Therefore, here it will be the 4 meters per second along the x-axis. Here 5 into sin 37 means how much now? 3 by 5. 3 by 5 I can tell now 3 meters per second now. So V1 we got it, this first particle, no, first particle 2 kg, no. So how much it will be? 4I plus 3j, right? This is your 4 along the x-axis, 3 along the y-axis upward, no. Now here again therefore 1 kg is going like this and like this, no. So therefore here it will be the 10, this side it is no cos 53. So 10 therefore sin 53. How much it will be? So you can write it, no. So 10 cos 53, 10 53 cos 53. 53 cos means adjacent side by hypotenuse, that means 3 by 5. So that is nothing but 2, therefore totally 6 I came along this one. So here what will happen now? 10 sin 53. Sin 53 means 4 by 5. 4 by 5, therefore 8 minus j cap. Why? Because it is downward. So therefore V2 I got it now. How much now? 6I minus 8j. Right? So therefore again use the same formula. Velocity of the center of mass m1. m1 is how much now? This is 2 kg into velocity of this how much now? 4I plus 3j plus 1 into therefore here 6I minus 8j. So by therefore 1 plus 2. How much it will be? Therefore 8 plus 6. 8 plus 6 how much now? 14. 14 I cap, therefore 6. So 6 minus, therefore minus 2j divided by 3. So how much now? 14 by 3 I cap minus 2 by 3 j cap, right? So here velocity of the center of mass is how much now? 14 by 3 comma minus 2 by 3. So this is your velocity of center of mass now. Clear? In this way you can calculate the problems now. Clear? Now let us see one more question here, no? Right, two particles are there, 2 kg and 4 kg are approaching towards each other with an acceleration towards each other means what will happen now? See here, we can do analysis here, no? This is your 2 kg going towards this side with what acceleration here, no? 1 meter per second square, and this is your 4 kg going with toward this one, no? 2 meter per second square. This is your A2. Clear? It is this is the x-axis, this is minus x-axis now. So we want to calculate acceleration of your center of mass means m1 m1 is how much now? 2 into, so 1, therefore I cap, no. So plus, therefore here 4 into minus 2, why? Because it's toward this side, divided by 2 plus 4. How much now? 2 minus 8 by 6, no. Therefore minus 6 by 6, no, minus 1. Therefore it will be I cap onto this. That means total acceleration is going toward this side, acceleration of your center of mass. Clear? So now let us see one more question here. Right. So here there is a 3 particles are there now. So 3 particles are there, 1 kg, 2 kg and 3 kg are subjected to these forces now. So magnitude of the acceleration, most of the students they will confuse here, no. So acceleration of your system, it will be equal to F1 plus F2 plus F3 divided by M1 plus M2 plus M3. Already directly forces is given, no need to multiply onto that. These are not accelerations, right? If it is accelerations are there, M1 A1 plus M2 A2 plus M3 A3, but here directly the forces are given, no. Therefore, so many students know what they will do, they will multiply this, that's all, gone everything. So these are the forces now, forces are given. Add these forces now, therefore 3I minus 2J plus 2K plus, therefore that is nothing but a minus I plus 2J minus K plus I plus J plus K divided by 1 plus 2 plus 3. Clear? So how much it will be now? This is minus I plus I get cancelled. Therefore 3I minus 2J plus 2J get cancelled out now. So therefore plus J 2K, therefore minus K plus K get cancelled, plus 2K divided by, therefore 5 6. So how much it will be now? Therefore here, so 3 by 6 I cap plus 1 by 6 J cap plus 2 by 6 K cap. Clear? So therefore 1 by 2 I cap plus 1 by 6 J cap plus 1 by 3 K cap. Clear? So this is your acceleration of your center of mass. Understood? Right. So this is one interesting question, no? Right? A lot of things are there, no, to solve here. So let us do one question here, no? This one, no? So acceleration of the center of mass. Here for this one also some trick is there. You can solve it, no, very easily, very quickly, no. So we know that acceleration of this. See here, what is the acceleration? I already did, right? It's like a upwards machine pulley problem. So this is m1 is greater. What you can write now? Acceleration here, no. I'll tell you a trick now here. No? This is acceleration A, not acceleration of the center of mass. Acceleration, what is the formula here, no? Whose heavier mass, no? m1 minus m2 by, therefore m1 plus m2 into g. This is your acceleration. Now what is the acceleration of your center of mass now? That means where is the center of mass? Suppose somewhere here, no, between these two the center of mass is lies. Now this will go down and this will go up. Therefore what will happen now? The center of mass, it will be always shifted toward the heavier mass side, no. So therefore somewhere here, no, the center of mass, it will be lies after traveling some distance. This one, no, after traveling some distance. So there is a motion of the center of mass is taken place now. Center of mass, it is moving from here. Clear? So therefore we want to calculate motion of your center of mass, no. So acceleration of your center of mass, no, m1a1 plus m2a2 by m1 plus m2. So these two are moving in opposite direction. Again you will get the same one, no. You can use the formula just. So it is, this side is negative j axis, this is your positive j cap now. Therefore just you can substitute it, no, you can get it your answer. Okay, we'll do it, no. So suppose here downward is, this is nothing but a minus j cap, no. So this is your plus j cap. Clear? So therefore m1, therefore a1, so a, therefore your minus j cap, right. So here j cap, no, therefore here plus, therefore m2 into a into j cap divided by m1 plus m2. Clear? So how much it will be now? Therefore m2 minus m1 by m1 plus m2 into, therefore j cap, no. Therefore j cap, no. Here actually the acceleration we take it here, no. Therefore you can substitute it minus direction by why. This is general acceleration, we did not do the direction, no. What is the acceleration? Downward, no. Therefore this should be actually minus j cap. Clear? So minus of minus this one, no, just here it is a, sorry. So a you can substitute it, no, you can get it as m1 minus m2 by m1 plus m2 whole square into g. This is your acceleration of your center of mass. So this, just for this one, you can keep the square, that's all, you can get your answer onto this. Clear? So and also they will calculate, they will ask you to calculate how much distance it is travelled after certain time, no. So we can rewrite it as velocity of the center of mass, no, it will be equal to initial velocity of your center of mass plus acceleration of center of mass into t. So distance travelled by this one, no, therefore initial velocity of center of mass into t plus 1 by 2 acceleration of center of mass into t square. Like this you can solve the problems, no, right. Now so you can substitute it, no, you can calculate what will be the distance travelled by this distance travelled after certain time, no, you can calculate it by using this problem, right. So here simple thing, no, we can quickly calculate it, no, what will be the acceleration of the center of mass. Okay, we will do acceleration, also we will do some questions here, no. Acceleration of center of mass, very quickly we can write it now. What is the formula? So m1 minus m2. Whose mass is more? This mass is more. This mass is going upward. Clear? So therefore 5m minus 2m, sorry, this 3m by 5m plus 3m into whole square into g. That's all. So this is 2m by therefore 8m whole square into g, get cancel 1 by 4, therefore g by 16 will be your acceleration of your center of mass. That's all. So suppose they may ask you what will be the distance travelled after time t is equals to 2 seconds. Suppose after time t is equals to 2 seconds, therefore distance travelled by the center of mass, right? So if initial velocity of the center of mass was 0, so what you can write it now here, distance travelled of the center of mass, no, it will be equal to initial velocity is how much, no, therefore u centimeter, so u center of mass into t plus 1 by 2 acceleration of center of mass into t square, this it will be equal to 0, 1 by 2 acceleration of center of mass is how much now, g by 16 into 2 square, how much it will be now, so 1 by 2 into g by 16 into 4, 4 ones are 4, 4 fours are, therefore g by 8 meters distance it is going to travel. So like this also you can solve the problems, no. So right, in this situation now, clear? Okay, so this also same thing. So suppose let us take this one, no. Therefore here now this is your 8 kg, this is your 4 kg, assume that this is a smooth surface, no. So this will go down with an acceleration, this will go up with an acceleration, sorry here no, these two strings are there, no, different strings, no. Okay, therefore here it is connected by this, no, there here inextensible, so it will be the same only, therefore acceleration it will be the same for this because it is a smooth surface now, right. So what will happen now, how to calculate the acceleration here now, I already did one short tricks video to solve the problems related to this acceleration and tension, no. So acceleration, what you can write it now, acceleration is nothing but a, so total force, net force by total mass. Total net force is how much now, this side it is 80 minus this side it is nothing but a 40 divided by total mass is how much now, therefore 4 plus 8 plus 8, how much it will be now, 40 divided by, so 16, therefore it will be 20 it will be, right. So how much it will be now, therefore 2 meter per second square. This is your acceleration of your center of mass now. So now we can write down acceleration, sorry, this is an acceleration of the system, acceleration of the center of mass. Suppose this side direction is nothing but a minus j cap, no, this side direction is nothing but a plus j cap, this side is nothing but a plus I cap, clear. So this is going downward, therefore what will be your acceleration of center of mass now, this is 8 into what is the acceleration here now, 2, but it will be minus j cap, no, plus 8 into 2 I cap now, because this is going toward this side, so plus this is going upward, no, 4 into, therefore here 2 j cap, clear, upward, divided by total mass, no, so 4 plus 8 plus 8, clear. How much it will be, so this is I is there, 16I, so therefore minus 16j plus 8j divided by 20, clear. So how much it will be here, 16I, therefore here it will be minus 8j divided by 20. So you can rewrite it as, therefore here 16 by 20 I cap minus 8 by 20 j cap. So this you can write down 8 by 10, therefore 4 by 10, therefore by 10 means 0.8 I cap minus 0.4 j cap plus 0.8. So second option will be a correct answer now, clear, right. In this way you can solve the problems, no. Okay, this is one of your JEE main question, no. So JEE main question on the center of mass now. if the system of two particles are there, m1 and 3 kg and 2 kg are placed at certain distance, we don't know what is the distance. So the particle of m1 is moved toward the center of mass of the system through a distance of 2 centimeter. In order to keep the center of mass of the system at the original position only, the particle of mass m2 should move toward the center of mass. Yeah. So here we can solve this problem very easily. Suppose there is a here 3 kg object is there now. This is your 3 kg, right? So therefore here it will be the 2 kg object is there now. Therefore here, clear now? So therefore certain distance is there, we don't know. Therefore there will be a center of mass, it will lies here now, right? So now what happened now? This object, okay, the particle of mass m1, this object it is moved toward this distance now. How much distance it is moved now? 2 centimeter toward this side. So this one, how much distance you have to move? So therefore here how much distance you have to move, so that the center of mass it will be like same only. That means this a shift is taken place now. The shift in this mass is taken place now, but there is no shift in the center of mass. So what is given now? No, he gave the condition no shift in center of mass. So that means delta x center of mass it will be equal to 0. So shift in the center of mass is 0. So what you can write it now? m1 into shift in the first object plus m2 into shift in the second object. It will be equal to 0. That's all. So you can rewrite it this problem therefore very easily. So this is 3 kg. Therefore how much distance is moved toward the x axis Therefore 2 plus m2. m2 is nothing but how much now? m2 is nothing but 2 kg. So therefore it will be shift is taken place therefore minus x it will be equal to 0. So how much it will be now? 3 into 2 it will be equal to 2x. Therefore x is equals to 3 into 2 by 2, therefore 3 centimeter. So it should move with a 3 centimeter distance here now. Clear? Clear? Now let us see here therefore here, right, both block A and B moves on a smooth horizontal surface which is equal speeds of 2 meters per second in opposite direction. At time t is equals 0, the position of the block as shown, right? So the center of the coordinates of center of mass of the two block system, t is equals to 3 seconds. After 3 seconds. Okay, coordinates of center of mass now. Therefore initially where is this one is there. Therefore we'll see okay. Initially where the center of mass is there, then afterwards we'll see So from here we can calculate what will be the center of mass here now. It is along the x axis only. So therefore here xcm is equals to, therefore 4 into 0 plus 4 into what is this distance now? 4.5 divided by 4 plus 4. How much it will be now? 4 into 4.5 divided by, therefore 2 into 4. 4 cancel. So this is now much 2.25. Therefore 2.25 centimeter. Clear? Therefore somewhere here the center of mass it is going to lies here. Clear? Center of mass is going to lies at this point onto this one. So here center of mass. Therefore after 3 seconds, therefore what will be the velocity of the center of mass now? So velocity of your center of mass so it is going with a 4 into 2 plus 4 into minus 2 because it is going toward this side by 4 into 4. So therefore velocity of your center of mass is 0. So velocity of the center of mass is 0 means what? So shift in the center of mass by time it will be equal to 0. Shift in the center of mass it will be the 0. That means there is no shift in the center of mass. So therefore the center of mass is going to lie at this point only. Therefore 2.25 comma 0. This is your center of mass. Clear? Right? So now here therefore there are two bodies are there, right? So we'll see one more question here now. So find the momentum now, right? Very simple one now. Right. So two bodies are there, 10 into 2 are moving with the velocities and find the momentum of the center of mass. Momentum of your center of mass it will be equal to m1 v1 plus m2 v2. So here it will be equal to 10 into So 2i minus 7j plus 3k plus 2 into minus 10i plus 35j minus 3k. Clear? So how much it will be now? Therefore you can write it as, so 20i cap minus 70j cap plus 30k cap minus here no minus 20i plus 70j cap minus 6k cap, right? So how much it will be? Minus, right, 70i and this 20i get cancel out no, this will also cancel out no, so 30 minus 6k, so therefore 24k cap. So will be your momentum of your center of mass. Like this you can calculate it. Very simple one no. Yeah, so I already explained at the starting point no. So here this is one theory question no. Let us see, there is a projectile is launched here now. So with one speed and making an angle at this point no, at the highest point of the trajectory the projectile breaks into two pieces. This is breaks into A and B. The mass of this is m and this is 2m respectively. Immediately after the break of the piece A and is at rest, therefore this is becoming at rest now, right? That means not moving onto this related to the ground. Therefore, so which of the following statements most accurate to describe what will happen now? Therefore, right. So here it is at rest means compulsory it will be falling here no. This it will be moving with this speed onto this. What is the speed? At the highest point. At the highest point no. Therefore what will happen now? What will be the velocity at this highest point no? V cos theta. So initial momentum no. Initial momentum. Therefore mv cos theta. So then afterwards what happened now? It is breaks into this one now. M and 2m. This is 3m, right? Therefore this it will become to the 0 v1. So v2 will be equal to how much now? This is going toward this side. Initial momentum, it is going with some speed. So initial momentum and final momentum both it should be equal no. Therefore initial momentum is how much now? So mv cos theta, so is equals to 2mv. Therefore v2, this momentum must become, and this momentum is become to the 0. Get cancel out now. v2 will be equal to v by 2 cos theta. This is your v2. Clear? First of all let us see what is going to happen now. Piece B will hit the ground first. No, therefore it is falling no, it is going right since it is more massive. No, therefore both are going to hit the ground at the same point now. Same time, this point is very very important. Why? So downward force it will be the same, so downward acceleration is also same onto this one no. So therefore here this is your wrong statement no, both are going to hit the ground at the same time. So both, because time it will be equal to square root of 2h by g. So right, it does not matter onto this. Both pieces have 0 vertical velocity immediately after the breakup. Yes, so they are breaking like this no, so there is no vertical motion onto this, right? Both pieces have the 0 velocity immediately after the breakup, therefore they hit the ground at the same time. Yes, so therefore this it will be the correct statement. Piece A will hit the ground first because it will be having the downward velocity. No, wrong answer. There is no way of knowing which piece will hit the ground because not enough information to break up. Right. Wrong answer. So therefore both are going to hit the ground at the same time, right? Like these questions no, you need to analysis onto this. Here also this nothing is there, no use, but okay, for this question no use, but you can solve the problems like this also. Okay, so let us see this question no. Right. So two particles are there, each of mass 2 kg, attract each other with a force inversely proportional to the square of the distance between them. That is nothing but a, so force is inversely proportional to the square of the distance no, is nothing but a gravitational force. The particles held initially at rest no, released, what will be the velocity of center of mass? There is no velocity of the center of mass here no, right? Why? Because there is no shift in the center of mass here. Clear? Right. So, right, this is also one of your JEE main or NEET question. No? So, two persons of mass 55 kg and 65 kg respectively are on the opposite ends of the boat. The length of the boat is 3 meters, weight is about 100 kg. The 55 kg man walks up and to the 65 kg, sits with him. If the boat is still in water, this is important. It is still in water. That means it will be, if they are going backward, so therefore the boat it will be going backward in this direction. The shift in the center of mass shift, there is no shift in the center of mass, 0. You understand? No? It should be very clear. Okay? And this one. Now, let us see this question. No? Initially, two stable particles are there. X and Y starts moving towards each other under mutual gravitational force of attraction. That's all. If one time of the velocity is x and y are 3v, so what will be the velocity of the center of mass? Velocity of the center of mass is 0. That's all, because they are moving under the velocity, mutual attraction force. Clear? Now, right. The particle of mass 200 grams is dropped from a height of 50 meters and another particle of mass 100 grams simultaneously projected upward from the ground along the same line with a speed of 100 meters per second. Acceleration of the center of mass after 1 second. Yeah, good question here. No? So, let us see the analysis onto this one. No? What will happen now? So, there is a height is there. No? This is your height. No? Right. So, their height it will be equal to 50 meters. So, here initially therefore, it is m will be there, no, it is dropped. Dropped means initial velocity is 0, goes down with an acceleration is g. So, let us take this one, no, downward is nothing but a minus j, upward is nothing but a plus j, that is all. So, downward therefore, what will be the acceleration here, no, minus j cap. Clear? Okay. So, therefore, here now another one more particle is there. So, this is of mass is how much? No, 100 grams. This is your how much? No, 200 grams. No, this is your 100 grams. Projected upwards with a speed of 100 meters per second. Right? Therefore, now, so therefore, here also acceleration is acting downward onto this one, no? That is minus j cap. No? What will be the, he is not asking the velocity of the center of mass, no? Acceleration of the center of mass. So, acceleration of your center of mass is how much? No? m1 a1 plus m2 a2 by m1 plus m2. So, while going upward, no, there is no change in the acceleration here, no? Right? m1 is how much? No? 200 grams into g, that is minus j cap. Clear? Plus 100 grams into minus g into j cap divided by 200 plus 100. How much it will be now? This is 300 minus 300 g j cap by 300 minus 10 j cap. Therefore, here 10 will be your answer on this. Clear? In this way, you can calculate it. No, it does not matter of the time. No, if they are asking velocity of the center of mass, no, then it will be the different one. No? Why? Because you have to calculate what will be the velocity after certain time. No, after time 1 second. What will be the velocity after time 1 second? No, then you can calculate velocity of your center of mass. So, as a homework, you try to calculate so velocity of your center of mass. Clear? So, now let us see. Right. Now, two particles are there. These are it. No, at time t is equal to 0, force is equal to 6 newtons. Starts acting on the 3 kg mass. the velocity of the center of mass of the particle after time t is equals to 5 seconds, right. So, t is equals to 5 seconds. 5 seconds means here, this is your 5 seconds. Therefore, here is asking velocity of the center of mass. Therefore, here this is your now this is not moving, only this is moving. What is an acceleration here now? Acceleration is equals to force upon mass now, 6 by 3, therefore 2 meter per second square. This is your acceleration of this one now. What will be the velocity, initial velocity? Velocity of the particle after certain time now. So, v is equals to u plus at, u is how much now? 0 plus 2 into, therefore, here it will be 5, therefore 10 meters per second. So, here this is not moving now. So, velocity of your center of mass now. So, VCM, you can write down m1 v1 plus m2 v2 by m1 plus m2. m1 is how much now? 2 into 0 plus 3 into, therefore 10 divided by, therefore 2 plus 3, therefore 3 into 10 by 5, 5 2s are, therefore 6 meter per second. This is your velocity of your center of mass, no, right? This 6 meters per second. Clear? Right. Now, at two spheres of mass m and 2m initially at rest, no. So, due to mutual forces now, mutual force, if you really get your right, this is your mutual forces now. Mutual forces, if it is there, no, acceleration are there for everything, it will be this acceleration of the center of mass, no, velocity is only 0, acceleration also will be 0, no need to think anything onto this. Clear? So, we will do final question here, no. Yeah, I already did this question, no, this type of question, no. So, in the starting of this. So, let us see, a man of mass m stands on one end of the plank, no. Okay, there is one plank is there, no, this is one plank. So, therefore, here there is a one plank, it is there, therefore, it is having length is L. So, therefore, m is there, no, m. So, which is rest on a frictionless surface, that means it is at a smooth surface now. A man walks on other of this or no. Okay, mass of the plank is m by 3. So, mass of the person is how much, no? Mass of the person is m. So, if he moves onto this, how much the plank will move related to the ground. That means I already taught you. So, when this person moves, no, it will move towards some x distance. So, due to this, what will be the shift in the center of mass? No shift in center of mass. That means delta xcm, it will be equal to 0. That means what you can write it now? m1. Therefore, m into how much distance he will move now? He will not move L distance, L minus x distance he will move. So, this plank, no. So, m by 3 will move x distance. It will be equal to 0. That is all, simplify. So, what you will get it now? ml minus mx, it will be equal to, so mx by 3 taken here, no. ml is equals to x taken common, m by 3 plus m. Clear? So, this is 3 4m. Therefore, here ml, it will be equal to 4m by 3 into x. Therefore, get cancel out, no. So, that is nothing but x is equals to 3l by 4. So, this it will be your answer now, right. This type of different questions now I already taught in the law of conservation of linear momentum, right. Now, yeah, right. So, thank you for watching. No, please subscribe to my channel and learn the physics very easily. So, we are discussing like a concept and it is applications, no, which is very useful for competitive examinations, even for board examinations, a complete learning, right. So, therefore, those who are preparing for competitive examinations like NEET, IIT-JEE, Advance, even teacher trainings onto this or no, right, government examinations, SAT examinations, no, this all it will be applicable, no. So, go through it. So, thank you for watching. Please subscribe to my channel.